Hello everyone. Today in this video lecture we will see an introduction to clustering with K-means algorithm. So first of all, let us understand what is clustering in unsupervised learning. So clustering is the process of dividing entire data into groups, also known as clusters, based on the pattern in the data. Clustering is an unsupervised learning problem. For example, a bank wants to give credit card offers to its customers. So currently they look at the details of each customer and based on this information decide which offer should be given to which customer. Now you know that the bank will have millions of customers. But does it make sense to look at the details of each customer separately and then make a decision? Certainly not. So it is a manual process and it will take a huge amount of time. So what bank can do in such situations? So one option is to segment its customer into different groups. For instance, the bank can group the customer based on their income. High income customers, average income customers, and low income customers. But how to group into these uh, different groups? So we will say it. So the bank can now make three different strategies or offers, one for each group. Here, instead of creating different strategies for individual customers, they only have to make three strategies. This will reduce the efforts as well as time. The groups I have shown above are known as clusters, and the process of creating these groups is known as clustering. So you can clearly see here there are three groups: high income group, average income group, and low income group. So in clustering, we do not have a target to predict, like we have seen in a classification problem that you have something to predict. But in this case, in clustering, you are not going to predict anything. That's why it is classified under unsupervised learning. We look at the data and then try to club similar observations and form different groups. Hence, it is an unsupervised learning problem. Now, what are the properties of clusters? So let's say the bank only wants to use income and debt to make this segmentation. They collected the customer data and used a scatter plot to visualize it. So in this picture, you can see on the x-axis we have income and on the y-axis we have debt. So by just mutual observation, we can see that you can classify this into number of clusters. So by visual observation, one may classify into two clusters, that is this cluster or this cluster. If we increase the number of clusters, so from 2 to 4, then someone may classify as this as cluster 1, this as cluster 2, this as cluster 3, and this as cluster 4. If we still further increase the number of clusters, then some may classify these three into one cluster, these three into another cluster, these three into third cluster, these into four, and so on. So on x-axis we have income of the customer and y-axis represents the amount of debt. So here we can clearly visualize that these customers can be segmented into four different clusters. I have just explained this to you. So this is how clustering helps to create segments from the data. So bank can further use these clusters to make strategies and offers to its customers. So let us see the properties. So property 1, all the data points in a cluster should be similar to each other. That is, this point must be similar to this point must be similar to this. It should possess the similar properties. Then property 2, the data points from different clusters should be as different as possible. So if we take the same example, if a, you group it like this vertically, so you have given with the two cases, case 1 and case 2. So which of these cases do you think will give us better clusters? So answer to this question is, let us consider both the cases one by one. So case 1, customers in the red and blue clusters are quite similar to each other. The top 4 points in the red clusters, that is these 4 points, share similar properties as that of the top 2 customers in the blue cluster, that is this. They have high income. You can see that they have high income and high depth value. So this is around here. So these two clusters share the similar properties, which is against the rule. Here we have clustered them differently. So it is against the rule that so according to the rules, this should be one cluster. So let us on the similar way, if we take this black colored cluster and this green colored cluster, so these the top 3 points in the black cluster and top 3 points in the green cluster share similar properties, but they are grouped into different clusters. Hence it is against the rule. So we will now discuss the case 2. So you can see that points in the red cluster are completely different from the customers in the blue cluster. So you can see that, so these red color customers are having high income, high depth value, whereas the blue customers having high income and less depth value. So all the customers in the red cluster have high income and high depth, and customers in the blue cluster have high income and low depth, as I have just explained. Hence, data points from different clusters should be as different from each other as possible to have more meaningful clusters. Now, the popular algorithm for clustering is k-means algorithm. So recall the first property of cluster, which states that the point within a cluster should be similar to each other. So our aim here is to minimize the distance between the points within the cluster. So there is an algorithm that tries to minimize the distance of the points in a cluster with their centroid. The algorithm is called as k-means clustering technique or algorithm. So k-means is a centroid based algorithm or a distance based algorithm where we calculate the distances to assign a point to a cluster. In k-means, each cluster is associated with the centroid. The main objective of the k-means algorithm is to minimize the sum of distances between the points and their respective cluster centroid. So to explain this, let us take a simple example. So suppose you are given with a scatter plot something like this, x1 and x2. So this variable x1 could be height or weight or any some variable. Similarly, x2 could be height or weight or any other variable. So by visually you can see that you can form the two clusters over here, this and this. So step 1 in k-means algorithm is to choose the number of clusters k. So by visual observation, we have selected k is equals to 2. Now step 2, select k random points from the data representing as its centroids. So we can randomly select this point as centroid 1 and this point as centroid 2, marked in red and green color. Step 3 is assign all the points to the closest cluster centroid. So this closest will be calculated based on the Euclidean distance, which is given by nothing but so we have already seen the how to calculate Euclidean distance in previous lecture. So we have to calculate the distance of all the clusters of all the points from these centroids C1 and C2. Now after calculating the distances of points from C1 and C2, so we can classify them as C1 in cluster 1 or K1. So all the red color dots, you can see that this dot or this point is nearer to C1. Similarly, this is nearer to C1. This is visually nearer to C1. Okay. Now this is the Euclidean distance of this point is nearer to C1. That's why it is categorized into cluster C1. Similarly, Euclidean distance of these 2 points is nearer to centroid 2. This is our step 3. Now, step 4. Recompute the centroids of newly formed clusters. So, we will be, so first cluster is this. We have formed this cluster as cluster 1 and cluster 2 as this. Okay. Now, we have to recompute the centroid by taking the mean of all the values in cluster 1. So earlier for starting the mean was assumed to be the same as this point. Similarly, mean for this was assumed to be as this point. Okay. Now after clustering, clustering these into cluster 1 and cluster 2, the centroid will be shifted. You will get it more when we'll take one example. So now the centroid is here. Now you will go on calculating. Just remember that this is x1, x2, it is the scatter plot. So now you will once again calculate the distance of all the points from this centroid 1 and this centroid 2. So recompute the centroids of newly formed clusters. In step 5, repeat steps 3 and 4. So after doing this, recomputing the centroids of newly formed clusters, this point goes here. So ultimately, final clusters are this. This is cluster 1 and this as cluster 2. But the problem is when to stop. So there are a few rules which will decide when to stop. So stopping criteria for k-means clustering. So we can stop the algorithm if the centroid of newly formed clusters are not changing even after multiple iterations. If we are getting the same centroid for all the clusters, we can say that the algorithm is not learning any new pattern and it is a sign to stop its training. Another clear sign that we should stop the training process if the points remain in the same cluster even after training the algorithm for multiple iterations. Finally, we can stop the training if the maximum number of iterations is reached. Suppose if we have set the number of iterations as 100, the process will repeat for 100 iterations before stopping. So let us understand this k-means the working of k-means algorithm with an example. So here we have taken one example in which you have total 12 points. So you have collected the data. So you have 12 student data, for example, and you have collected height and weight of 12 students. And you are given with a task that to cluster this. So initially I have plotted. You can see that the scatter plot here. Okay. So by visual observation, you can see that there are two separate zones. One is height lesser than 175 and other zone is height more than 175. So by visual observation, we can select the value of k as 2. Again, the selecting the value of k from vary between 2 to number of observations. So your k can vary from, okay, there will not be one cluster because there will be no point in that. So from 2 to number of observations. So maximum is the number of observations you are having. Again, there are a few methods to select optimum value of k. There is one elbow method and more methods. But for this learning, that is not in our scope. So we will restrict this to visual observation. But this visual observation will not help if the data points are very close to each other. Okay. So by visual observations, we have selected the value of k as 2. Okay. Then step 2 is select the k random points from the data as centroids. So I have selected the first two rows as centroid. So this red color dots indicating the centroid 1 and centroid 2. So I have highlighted this as K1 and K2. So 185.72 is the centroid 1 and 170 and 56 is centroid 2. Now next step is assign all the points to the closest cluster centroid. Now for doing that, we need to calculate the Euclidean distance. So we have already seen how to calculate the Euclidean distance. So you can see that, you can just see the formula. So it is square root of h45 minus h45 square plus I45 minus I45 square. So it will come out to be 0 as it is calculating the distance from on. But on the here you can see that it is H46 minus H45 square plus I46 minus I45 square. So similarly, we have to calculate the distance of all the points from the centroid 1 as well as centroid 2. So let us see this for K2. So I have calculated the distance, Euclidean distance from K1 and K2. And now, based on the distances from K1 and K2, we will be classifying or clustering this into K1 and K2. So we can see that here the first serial number point, that is this point, 1 is naturally it will come in the same cluster K1 because it is the same point at the same centroid. Then 2, again its distance from K2 is 0 and hence point 2 is classified into K2. If we select observation 3, then 4.47 is less than 20.81. So serial number 3 is classified into cluster 2. So instead of saying K1 and K2, I will say cluster 1 and cluster 2. And here I will use the terms centroid 1 and centroid 2 just to avoid the confusion. Okay. So I will use here also C1 and C2, cluster centroid 1 and centroid 2, and Euclidean distance of points from centroid 1 and centroid 2. Okay. So similarly for fourth row, 7 is lesser, the distance is less, hence it is classified in cluster 1. And similarly you can see all the points, the 6, 7, 8, 9, 10, 11 and 12. You can see that all the points are getting clustered into cluster 1. Only 2 points are there in cluster 2, that is serial number 2 and serial number 3. Remaining all the points got classified into cluster 1. Now next step, recompute the centroids of newly formed clusters. Now what we have to do, we have to take average of, that is new means, as the name of the algorithm is k-means. So we have to calculate the means of this new mean of this points and these points. So the new mean or new centroids, I will name this as C1 new and C2 new centroids. So how am I going to calculate it? So we just have to select all the points. These are to nothing but the height and weight. So all the points which got classified into cluster 1. So I am selecting 1 and 4, 5 up to 12. So you can see on the status bar that the average is 181.4. So that average is here, written over here. Similarly, for this weight, you can see that average is 7, but not that point. Average is 74.5. Okay. And similarly, I will select for cluster 2 new the average of serial number 2 and 3. So 2, 3, average is 169. and 56 plus 60 by 2, which will give you 58. So these are the new centroids now. Just to explain this graphically, we can see that here you can see the 2 cross indicates the new centroid. Okay, we can see that 181.4, 74.5 and 169, 58. So these two red cross indicates the new centroid. In previous case, it was these two red dots representing the actual points which we have got selected. And now these are the new means. Now once again repeat step, that is 2 and 3. Okay. So again, after repeating, we need to calculate the equivalent distance from new centroid. So I will write here new centroid and C2 new. Right. So I have calculated the equivalent distance from these two, C1 new and C2 new, and again I have reclassified into as cluster 1 and cluster 2. Right. So you can see that between these two 4.38 is lesser, so I have classified into cluster 1. Similarly for second 2.24 is lesser, so it got classified into cluster 2. For serial number 3 2.24 is lesser, so again it is classified into cluster 3, cluster 2. And for 4, 5, 6, 7 up to 12, you can see that these are the lessers. That's why it got classified into cluster 1. So since the clustering has not changed our centroid or classification, in this case you are getting the same clustering, and here also you are getting the same clustering, and hence your algorithm will stop over here. Otherwise, this process of repeating step second and third will keep on continuing. Okay. So you can see here that these are clustered into two clusters. One is this cluster and second is all these big clusters. So you can try for more number of k, that is you can select k is equals to 3, k is equals to 4, and just check how it clusters your data points. So I hope the k-means clustering is clear to you. So if you have any queries, you can send it to untwistedlearning@gmail.com. Thank you and have a nice day.